Okay, we're going to do a discrete probability table. Remember, it's discrete because there are certain categories that you must fall in. Now, in this case, I decided I'd go with a little different example because what I have is this ball team, has come in first place once. It's come in second place 3 times. It's come in third place 7 times. Come in fourth place 5 times. Fifth place 2 times. And sixth place 1 time. Now, the reason I did that is because these were listed as a frequency distribution. I can't really use them in this format. I need a px. So I need to change to px. So I have a total of 10, 15, 19 total games or total times or total whatever. So what I need to do is I need to come through and say, well, what's the probability that they come in first? 0.053. Well, how about 3? How about 3 out of 19? And so on and so forth. Okay, by sheer dumb luck, once I did these probabilities, 1 out of 19, 3 out of 19, 7 out of 19, etc., I got 0.053. I went to 3 decimal points just because I thought the rounding might be a little harsh otherwise. You could have just as easily gone with 2 for your probability, 2 places for your probability. And also by sheer dumb luck, when I added them all up, they actually equal 1. When you do it in this way, it won't always quite equal 1 because of rounding error. Now, I've gone through, and the next thing we need to do is to actually do the problem. I need to find the average. Well, that's xpx. So that's this times this equals that. Well, that's easy, 0.053. I've cheated and plugged them into my calculator already. So that 2 times 0.158 is 0.316. 3 times 0.368 is 1.104. 4 times 0.263 is 1.052, etc. Okay, I've filled in the rest of the chart. I've added the whole chart up, and I came up with 3.368, or approximately 3.4. Now, folks, this should make some sense, because if I look over here and say, what place should they come in? Probably not first. Second's getting better. Third's pretty good. That's the highest number. Fourth is still pretty good, so it makes sense that I'm going to be coming in somewhere between third and fourth. Now, to find the standard deviation, however, whereas mu was the sum of xpx, standard deviation is going to be the square root of the sum of x squared px minus mu squared. So, let's see if we can put this together. First thing I need is an x squared pile. So that's 1, 4, 9, 16, 25, 36. I need to get an x squared px pile. So I'm going to take px times 1, and I get 0.053. I'm going to take 4 times 0.158, and I get 0.632. And I'm going to do the same thing the remainder of the way down. 0.368 times 9. Okay. I have finished putting those together, so this times this, this times this, this times this, this times this. Got all those, I added them all up, come up with 12.738. So if I were to plug this into my formula, this whole component is 12.738 minus, now I can take 3. We'll use all the decimals since we have them handy. 3.368, and I want to square that. That's 11.34. If I do that subtraction, I come up with square root of 1.3 1.394. So 1.39 seconds. Square root that guy. And I come up with 1.18. And so my standard deviation, 1.18. That means if I'm going to chart it out, 3.4 in the middle, 4.58, 5.76, and finally 6.94. If I went the other way, it would be 3.4 minus 1.18, 2.22, minus 1.18, 1.04, minus 1.18, that is negative 0.14. And in fact, that is probably our best chart yet, because we've gotten a really good balance on each side. Okay, again, we still have a problem that we can't really go below 1, but you get the idea. So that's your discrete probability, that's your chart, that's the process. Hopefully that helps, folks. Good luck.